Let's begin with one more example of solving a system of linear equations. This is a, an example in which we will have infinitely many solutions. Let us write the coefficient matrix here first. The coefficient matrix is A, and the rows of A are nothing but the coefficient of the variable in the equations. So first equation has coefficients 1, 1, 1. So that is 1, 1, 1 is the first row. Second equation has coefficients minus 2, 2, 1. So it is minus 2, 2, 1 is the second row of A. Third equation has minus 1, 3, 2. So that gives me the third row, minus 1, 3, 2. The variable matrix is x1, x2, x3, and the B matrix is the entries in the right hand side of the equations. This is 3, 2, 5. Again, as we did in the previous examples, we will start with the augmented matrix and reduce it to row echelon form. The augmented matrix is written by writing the rows of A in the first part and writing the columns of A in the first part, and last column is augmented by the column in B. So it is 3 to 5. So 3 to 5 is augmented here. So now we have to reduce it to row echelon form. How can we do this? So first non-zero column is this first column itself, and topmost entry is non-zero. So this becomes my first pivot. So I have to reduce these entries to 0. So apply this row operations. We have done enough examples how to decide this row operations. So I'm not going to spend much of time here. So this is after applying this row operation, this is the matrix. So here we are now going to concentrate in this portion, dotted portion. So here first non-zero column is this one, topmost entry is this. So this is my second pivot. So once this is pivot, this need to be reduced to 0. So we apply this operation to make this entry 0. So finally the reduced matrix is this one. Now look into it. First pivot is this, second pivot is this, and the third row is 0 row. Now every non-zero row got its pivot. It means this is in echelon form, row echelon form. So this is in row echelon form. Now we note down the row echelon form of the augmented matrix. Row echelon form of the augmented matrix is this, and number of non-zero rows here is 2. So rank of AB is 2. Similarly, row echelon form of A is which is obtained from row echelon form of AB by taking the first 3 columns. So here first 3 columns we are taking 1, 0, 0, 1, 4, 0, 1, 3, 0, and this gives you the row echelon form of A. Here also you observe 2 non-zero rows. So rank of A is 2. Now once we have decided the ranks, now see what we see is that rank of AB is rank of A, and that is equal to 2. So when these two ranks are equal, the system is consistent. It means the system has a solution. Now since these ranks are equal to 2 and that is less than the number of unknowns, so this condition signifies that the system has an infinitely many solutions. So we'll write, since this is less than the number of unknowns, rank is less than the number of unknowns, so the system is consistent and has infinitely many solutions. See, consistent is coming from this fact that rank of AB and rank of A are equal. So that this is enough to claim that the system is consistent, means it has a solution, and has infinitely many solutions coming from this fact, that rank of rank is less than the number of unknowns. Now how to get the solutions, infinitely many solutions, we will see in. Note that the REF of AB is this. Now again recall that the first column entries are nothing but the coefficients of x1. second column entries are nothing but the coefficient of x2, third column entries are nothing but the coefficient of x3. So we will designate these columns by x1, x2, x3, and the last column is due to b. Now recall the definitions of leading and free variables. So here we got a pivot in first column and second column, and they are due to the variables x1 and x2. So x1, x2 are my leading variables, okay, and x3 column has no pivot, so x3 is my free variable. So we note x1 and x2 are leading variable and x3 is a free variable, So free variable means this variable is can be assigned any value. So what we do is put x3 is equal to c. It can assume any value, any real number as its solution. Put x3 is equal to c. Now again you go back to the row echelon form and use the rows to get the solution of the other variable. So here the second row is 4, 3, 8. So we rewrite this use this row to write my first equation. So R2 implies that this is 4x2 plus 3x3 equal to 8. So 4x2 plus 3x3 equal to 8. Solve it. x3 is already, we have assumed it to be c. So put it here and get x2. So what is x2? We are getting is 2 minus 3 by 4c. 2 minus 3 by 4c. So we got x3 is c, x2 is 2 minus 3 by 4c. Now let's see what is x1. So to get x1, so we'll again go to the first column of the row echelon form. What is it? 1, 1, 1, 3. So it means the equation will be x1 x plus x2 plus x3 equal to 3. So using R1, what we get is the equation x1 plus x2 plus x3 is equal to 3. But we have already obtained x2 to be 2 minus 3 by 4c and x3 to be c. So use these values here. x2 we replace by 2 minus 3 by 4c and x3 by c and solve it for x1. And x1 we get as 1 minus 1 by 4c. Finally, the solution is, therefore the required solution is x1 is equal to 1 minus 1 by 4c, x2 is equal to 2 minus 3 by 4c, and x3 is equal to c. And what is c? Where c is any real number. You can easily see that take c is equal to 0, you get one solution. Take c is equal to 1, you get another solution. Take c is equal to any value, you get a solution of the system of equation. And that is how you are actually writing infinitely many solutions for the problem. Thank you.